Okay, YouTube, in this video we're going to focus on how to solve polynomial equations specifically, and let's start by defining what we mean by a polynomial equation. Essentially, anytime that you have some polynomial set equal to some other polynomial, we refer to this as a polynomial equation. So you see three examples of this in either of these instances here, but I will say this: when we solve these, we often tend to set one side of the equation equal to 0, and what we do is we refer to that as the general form of this equation. So for all of these equations right here, if you asked me to solve them, I notice that we have a couple of polynomials set equal to each other, and we want to know what x values would cause this to be true. But I would, for instance, in this first expression here, first equation, I would bring the 14 over here to set the right equal to 0, or bring this 4 over here to set the right equal to 0, or I would transport the 4x plus 4 and subtract that from both sides to bring it back to the left and set the right equal to 0. But essentially, what I can say is when you solve a polynomial equation, we're nearly always going to solve this by factoring. So I've got a couple of examples here that we'll work through of polynomial equations, starting with checkpoint 1 here. It says solve by factoring. So when we solve by factoring, recall that what we're doing is we're playing upon the zero product property, which says if I can write this as a factored expression and it's set equal to 0, then either A is equal to 0 or B is equal to 0. But we're allowed to say this 100% of the time as long as the factored expression equals 0. So the first thing we want to do here is clear the right-hand side. So I am actually going to subtract 12x squared here from both sides. So we end up with this expression here, 4x to the fourth power minus 12x to the second power, and this is all equal to 0. Now that we have this in this general form, what we're going to do is we're just going to factor this. So factoring methods, we always check for a greatest common factor first. I notice that 4 is a factor of both of the coefficients, and they both have an x squared that they can give. So we'll factor out 4x squared, and we end up with this here. We get x squared minus 3 is equal to 0. So now that I notice that we have this as factored as we're going to get it, what we'll do is we'll take each of these individual factors in this product here and we'll set them equal to 0. So for instance, we're going to go over here, we're going to say, well then either 4x squared equals 0, or we'll go over here and we say, or x squared minus 3 is actually equal to 0. So what we end up with here is an instance where we would divide both sides by 4. We get 0 divided by 4, of course, is 0, and then we could just take the square root of both sides of this equation. And we would get x equals 0 or 0. And I know we don't get plus or minus in front of a 0 here, but we get 0 twice for an answer. For right now, let's just focus on the fact that we get 0 as our solution. And then over here, we'll add 3 to both sides. And once we do this, we get x squared isolated. So we'd say x squared is equal to 3. And then we'll take the square root of both sides. And this is very important. But when we take the square root of something, we have to write plus or minus in front. So the solutions here, if we were to write these out, we would say x is equal to negative square root of 3, positive square root of 3, and 0. Okay. And I also want to point out that we could verify this graphically. So one thing that I've done here is I've taken both sides of this equation, 4x to the fourth, and I put that in as y1 in my calculator. And I also did the same for 12x squared as y2. And I'm just going to point this out. My window is slightly altered so that we can see this nicely. But what we're really asking for is, are there any x values that would cause both sides of this to be equal? Or in other words, are there any x values that would cause y1 to be the same as y2? So when I hit graph here, I notice that there are 3 spots on my graph at which our graphs cross. So we have this initial graph and then this parabola here. But I notice they cross here, and they're at the same height there, and they're also at the same height around 0. So looking back at our solutions, we said, well, when x is equal to 0, these two y values are the same, and we can see that the graphs are the same there. Also, the square root of 3 is roughly about 1.7-ish, and you can see when x is equal to about negative 1.7 and when x is equal to positive 1.7-ish, we get two graph spots that are the same. Likewise, if we go look at our table of values here, I can see that when x is equal to 0, we have y1 and y2 are equal. And I know that I'm not going by increments of square root of 3, but if we did, that's kind of an interesting thing. We could see that they'd be the same. I wonder, I've never tried this. We say, let's go by root 3 increments here on our table. And we'll hit starting at 0. And I'll go back to my table. But you can see at positive square root of 3, which is about 1.7 there, we both are at 36, at a height of 36. And likewise with negative 1.732, which was this other square root we found here, they're both at 36. So taking a look at this next example, let's go ahead and start again by clearing the right-hand side. I'm going to bring all of these terms over to the left. And we end up with this statement here. We have 2x to the third plus 3x squared minus 8x minus 12, and this is all equal to 0. So in terms of factoring methods, I recognize that if this is a polynomial, has 4 terms, that often we use this factoring method called grouping. So I noticed that these first two terms both have an x squared in common, and we could factor that out and leave behind a 2x plus 3. And I also notice over here that these both have a 4 in common. Because this is negative here, and because I want to leave behind a positive 2x plus 3 on the inside, I'm actually going to factor out a negative 4. So you notice that I put this plus here. That's important. We say negative 4 comes out front, and if I do that, I'm left with 2x plus 3, and this equals 0. So again, if I notice here that this times this plus this times this equals 0, I can factor out this common factor of 2x plus 3. This is just our grouping method of factoring, and we're left with x squared minus 4. So to continue solving this, of course, we always check to see if we can keep factoring, and I notice that that right there is a difference of squares. So we end up with these conjugate pair factors. And so this is beautiful because now we can say that this times this times this is 0. Either 2x plus 3 is equal to 0, or x plus 2 is equal to 0, or x minus 2 is equal to 0. And solving each of these on the right here, I get negative 2 here when I solve for x, and I get positive 2 when I solve for x here. Here, on the left, we would subtract the 3 and divide by 2, so we get x is equal to negative 3 over 2. So our set of solutions here would be this set containing, it looks like, negative 2, negative 3 halves, and 2. And I just put them in that order because I like increasing order, but you don't have to. So that's how you'll solve a polynomial equation. Set it equal to 0, factor it, and then we'll just set the factors equal to 0 and solve those. Easy.